Hey guys, so today we're going to go over simplifying radicals. So the first thing we need to talk about are these really special numbers called perfect square numbers. And so on your yellow sheet, you should have these listed. And why we call these perfect squares is because they literally are a square, guys. So literally the square sides of each of these, this guy's a 1 by 1, which means when I take 1 times 1, the square root of that is literally just 1. So a lot of you notice that this would be a 2 by 2 in the next one, which is 4. 2 times 2 is 4. And it ends up that the square root of 4 literally is 2. And why is because 2 times 2 makes the square of 4. The square of 9 comes from a 3 by 3 square, so that equals 3. A 16 comes from 4 by 4, so that's why it equals 4. 25 comes from 5 by 5, so that's why it equals 5. 36 comes from a 6 times 6, and 49 comes from 7 times 7. 64 comes from 8 times 8. 9 times 9 gives you 81, and 10 times 10 gives you 100. Okay, so with these perfect square numbers, we're now going to learn 2 different ways of how you can simplify radicals. So this is the first one I want you to write in your notebooks for me, please. So the first method is to multiply the 2 numbers that multiply to make 24. So find me the factors. So 1 and 24, 2 times 12 would give me 24, 3 times 8 would give me 24, and 4 times 6 would give you 24. Now, the one you're specifically looking for here is any perfect square. Now, 24 is not a perfect square. 2 is not a perfect square. 12 is not a perfect square. 3 is not a perfect square. 8 is not a perfect square. But 4 is. And 4 is a very special number that ends up being a 2 by 2 square multiplied by our inside here. And because of that, then we can rewrite this to simplify. The key word here is simplify this radical. That means to rewrite me with something outside and something inside. So in this specific case, the 2 is going to break outside because it's my double, or my 2 by 2. It's a square. And the 6 stays locked in because it's left over, the remaining piece of my square. All right. So another method that you could use is, instead of writing a bunch of multipliers, is use the number 24. In your list of perfect square numbers, 24 is way smaller than 25. So we're going to mark out all of the perfect squares that won't work. And now we're going to test all of the ones that are possibility. You're going to use your calculator and take 24 divided by 16. That gives us a decimal, which means that I cannot use this one. Strike it out. 24, if I divide it by the perfect square of 9, it ends up giving you a decimal again, which means that we cannot use that as our number. 24 divided by 4 literally is 6, and that's what we want to use. That means 4 times 6 would give us our answer, and 4, my dears, come from 2 times 2. And then don't forget about timesing by your 6. And again, we end up coming out with the fact that our perfect square here is a 2 that is doubled here, or a 2 that's being multiplied together. So our square comes out and the leftover stays in. So our simplified answer to the square root of 24, guys, is 2 square root of 6. Make sure to write down example number 2 for me, and we're going to do exactly the same strategy. So method 1 is write out all the possible things that multiply to give me 128. Those of you that like the powers or the perfect squares list, 128 is bigger than all of those, so you need to start dividing. So in our first method, you're going to just multiply those numbers out for me. And notice that we have 2 perfect numbers that end up happening, actually 3 in our list here. That means that 1 times 128 I can't use. It's not useful. Now, when you look for your perfect squares, these are numbers that come from a perfect square. It literally is a square, guys. So this one right here ends up giving us 2 times, our square is 64. That comes from 8 times 8 as a square, which means the 8 comes out and the 2 stays in. Now, why we don't use the 4 and the 32, guys, is because it's not the most simplified. You want the biggest number that is a square. That means we don't want to use 4 and we don't want to use 16. It's not big enough. You want the biggest guy that goes into it. All right, so same idea with your square. So if you use your list of perfect squares, you're going to take what you have, the 128, and divide it by 100. That ends up getting you a decimal, which means we don't want to use it. If I take 128 and divide it by the next perfect square down, which is 81, we end up getting another decimal, yuck. But if we use 64, we end up getting a number back, and it is my biggest number that I can use to make this work. So we're going to do 64 times what is left from that division, which was a 2, by the way. And you know something about 64. That ends up coming from a perfect square of an 8 by 8 makes 64, which means the 8 breaks out because that is my square, and the non-square piece stays on the inside. So the square comes out, and the non-square piece stays in. So your square comes out, and whatever remains or the leftovers get stuck inside. Okay, last one for our example. List out your numbers or just check it off here. If you go about the first method and you give me all of your factors, pay attention to the factors that are perfect squares. So we're not going to use 1 and 64. We're not going to use 2 and 32, but I do want to use the biggest ones that I've got here. So you could use 4 and 16, but you know something about 4 and 16. 4 comes from 2 times 2, and 16 comes from 4 times 4. Which means a 2 comes out in my final answer, and a 4 comes out in my final answer, which ends up giving us 8. Now, the cool part about this is a perfect square, guys. 64 comes from 8 times 8, which means that 8 is my final answer. Now, you also could have done that over here in your lineup. 100 is not there, but 64 is the guy I have. And 64 comes from 8 times 8. That is a perfect square with nothing left over. It literally is 8 as my simplification. Your turn to practice.